Hello, I'm Jordan Ansari, Applications Engineer at Analog Devices. I will be unboxing the ADMX2001 Precision Impedance Analyzer Kit and demonstrating how quick it is to get started. With the ADMX2001 module, you will be able to make impedance measurements with an unmatched combination of precision and size. Make sure to order both the ADMX2001B, which is the measurement module, and the EVAL-ADMX2001EBZ, the evaluation board for the module, as both boards work together to complete the ADMX2001EBZ LCR Meter evaluation kit. Inside both boxes, you'll find everything you need to get started. In addition to the PCBs, test leads, a power supply, and a UART to USB cable are all included. Getting connected is a breeze. Start by installing the FTDI drivers to prepare the PC to communicate with the board. Once that is done, shift over to the hardware. Plug the ADMX2001 module into the EVAL-ADMX2001EBZ and connect the UART breakout pins of the USB to UART cable to the eval board, making sure to connect the black wire to ground, the yellow wire to RX, and the orange wire to TX. The labels for each are located on the silk screen. Then, plug in the USB side of the cable to the PC, making sure the COM port is recognized on your device. If there is no connection found, try to install the latest drivers. Test leads are color-coded, ensuring proper connection to your testing components. Connect the BNC cables from the red clips to the H-Cur and H-Pot connectors, and connect the BNC cables from the black clips to the L-Cur and L-Pot connectors. Power to the evaluation board is supplied via a DC input, which accepts 4.5 to 12 volts. Connect the 9-volt power supply provided first to the power jack on the eval board, and then plug the other end into an outlet. We will be demonstrating the command line interface that is available when communicating to the boards via UART, but we also support communication to the module via SPI. These pins can be accessed through the Arduino headers. We recommend using the Teraterm terminal emulation program to connect to the virtual COM port created by the USB to UART cable. Start the program and select the correct COM port, then configure the serial port settings for 115,200 baud, leaving the other defaults as is. Press Enter within the terminal, and the ADMX2001 prompt should appear, indicating that you have established communication to the module. If you want to verify further, type the command *IDN ? And press Enter, and you will see the firmware version and your module's unique ID. To view the list of supported commands, type Help and press Enter. If you want more details about a specific command, type Help followed by the name of the command. Take Display, for example, and press Enter. This will give you a verbose explanation of what that command does, the options available, and the format of what values and parameters can be passed in. To make a measurement, simply attach the component to the test clips, making sure to hold it by the leads only. By default, the gain is set for auto range, a test signal magnitude of 1 volt, and a test signal frequency of 1 kHz in the series resistance and reactance display mode. Type Z and then press Enter to make a measurement. The result will appear in the terminal displaying the impedance followed by the reactance. If desired, you can also change the number of averages performed per measurement by running the average command, and even change the number of measurements displayed by running the count command. Sweeps over frequency and amplitude can also be run by using the sweep type command to configure the parameters. There are several options to extract the data from the terminal window. The first option is to copy data directly from a terminal and paste it into a text file. Simply open up the file within Excel and use the text import wizard to import the data. Choose delimited as the data type, click Next, then choose comma as the delimiter and click Finish. The second option is to use the log feature if you have selected Teraterm as your terminal emulator program. This can automatically save the terminal output to a text file or directly as a CSV. Once you have the data in Excel, you can begin generating plots. We hope this unboxing and quick start video for the ADMX2001 LCR evaluation system was helpful. Note that for the best performance of the module, additional compensation and calibration may be required. For information on these procedures, deeper insights, and an enriched journey, head over to analog.com/eval-ADMX2001 for a comprehensive overview and links to the wiki page user guide.